Okay, I forgot to start recording. So today is 1/13/16. So we reviewed a little bit about abiotic factors, and you guys named a bunch of them. And if you remember, we drew this picture a bunch of times. We said, you know, for any condition we could talk about, for the amount of precipitation, for temperature, for the amount of sunlight that a plant gets, there is a region, there's a set of conditions under which that organism is doing great. They are fantastic. And then there's a region where they are able to, you know, survive. They may be able to grow, but they're probably not capable of reproducing. You understand that reproducing, you have to be in like top shape to reproduce, biologically. It's not like you don't have to be able to run a 4-minute mile or anything. But if your body perceives that you're not doing so well, that your own survival is at stake, your body shuts down reproduction. This happens in people who have been near starvation. So how many of you have seen film of people who survived the camps in Germany during World War II? Okay, those walking skeletons. Those people would not have had any ability to reproduce. When you see people who've been through something really physically traumatic or taxing, their body will shut down reproductive function. For males, this means they literally stop producing sperm. For females, it means they stop ovulating. They stop having a menstrual cycle because their body says, hey, you know what? You're on the thin edge of survival yourself. We can't afford the energy for somebody else. So, you know, in this green zone, what we'll call it here, this is thriving. You're able to grow, you're able to reproduce, you can do all that. Life is good. You can grow, you can reproduce, you're successful. Life is good. Under whatever conditions this might be. And you know, this might be temperature. If we put you in conditions where your body had to fight to maintain normal body temperature, you would probably lose the ability to reproduce. If we put a child, for some reason, in a situation where they had to fight to maintain a normal body temperature, either too hot or too cold, their growth might be stunted. So let's look at this yellow zone then. So the yellow here, this is okay. You know, you probably can grow. You probably can't reproduce. So for plants, like this is a flowering plant here. It could produce flowers. A lot of house plants don't ever produce flowers. What are flowers for a plant? Babies. They're reproduction. Most house plants are not in such a good spot. You know, it's whatever conditions this plant evolved in the wild, I'm not totally meeting it. And I think this is a tropical plant. It's probably a little bit cold in here, honestly. It's probably used to like a really moist environment. Like if I had this in some, you know, fancy tropical style greenhouse, maybe it would be happy enough to reproduce. It's still growing. It's fine. It looks healthy. But it's not in such a good spot that it's going to reproduce. It's not going to waste energy on that. So that's that yellow zone. You may be perfectly healthy. You may be fine. But not so healthy that you can afford the energy to reproduce. Now, the orange zone, we'll do that one over here. That orange zone is bare bones survival. Okay? So in that orange zone, you're probably not growing. You're definitely not able to reproduce. You're just hanging on. You're just making it. And there are, and I know we talked about this before, at the end of World War II, there was what they called the Dutch starving winter. And there were people who went through that winter, like there were no calories. People were eating rats and tulip bulbs. Tulip bulbs are poisonous. And people were so desperate they were boiling them to try to sort of neutralize the poisons and then eating them anyway. You know, like rat and tulip stew. I mean, this was hardcore starvation. There were no calories available to people in large parts of Holland right after at the end of the war. The people who lived through that as children are shorter than their siblings who were a few years older than them, are shorter than their siblings who were born after the war. They were denied calories at such a vital point in their development. They lived. Yeah, so people who survived that Dutch starving winter literally had their development stunted for the rest of their lives. They were in that survival zone. They survived, you know, but just barely. So that's that survival zone. Do you remember, we talked about what we call this chart a little bit last week. We just kind of introduced the idea. Anybody remember? I'm going to give it to you in a second. I wanted to see if you remembered. No. Okay. So this type of chart is called a tolerance curve. Okay? Because how well something performs under changing conditions, we can make a visualization of it. And this is a tolerance curve. So, you know, I really like this graphic of the tolerance curve. It's better than anything I could draw because it shows, you know, this is what's true for the individual. You know, if conditions are above this point, you're capable of reproduction typically. If conditions are above this point, you're capable of growth. You're still able to grow, so you're doing okay for yourself. If conditions are, you know, at that point, that's the borderline of survival. Oh, what we didn't mention is, what's this red zone? Death. Yeah. Those are the conditions that you can no longer tolerate. So during the Dutch starving winter, to take it back to the historical example for humans, you know, we had lots of people hanging on in the orange. Did some people move into the red? Yes, lots of people. There just weren't enough calories available in Holland to sustain all of human life that had started off there. So yeah, we can do this graph the same way we did that one and color it in. And we've got the red, the orange, the yellow, and this nice happy green zone where life is good. So what I like about this is that it says, well, yeah, it's only within that range that the population is actually going to grow. Why? Why will the population not grow outside of the green range? They can't reproduce. Yeah. If you're outside the green range, you're actually going to see the population start to shrink because individuals in that population aren't able to reproduce. They're too much on the border themselves to reproduce. You know, it shows here you can have individual growth. Individuals can still grow, but the population isn't growing. And then out here is where everybody's just hanging on. And obviously, if you're that close to the survival range, a lot of individuals in the population will not make it. You know, when life gets tough. So this is a tolerance curve. What I would like you to do now is go to PB Works, there is a quiz on this material. So this is less a recall quiz and more of an understanding check. You go to PB Works right now. You're going to take that quiz, and we'll run the grades for it immediately.